So what is residue? Let us recall residue. So residue simply if f of z is not analytic at z equal to z naught, that means z naught is a singular point. Then f of z has a Lorentz series expansion in the immediate neighborhood. In the immediate neighborhood of z naught, that is 0 less than mod z minus z naught less than r of the form f of z equal to sigma n equal to 0 to infinity a n z minus z naught all power n plus sigma n equal to 1 to infinity bn divided by z minus z naught all power n, and this is valid in this neighborhood. Okay, so residue is simply means residue is equal to, okay, so residue of we denote it by residue of z equal to z naught at f of z is simply the coefficient of 1 by z minus z naught. So in the Lorentz series expansion, so the coefficient of 1 by z minus z naught is residue. And we already studied few formulas how to find out residue of a function. So, and also we studied residue integration theorem. Residue theorem, that is if f of z is analytic everywhere inside and on a simple closed curve C, except finitely many points, that is let it be z naught, z1, z2, etc., zk, then integral over c, that means f of z is analytic everywhere except some points z0, z1, z2, etc. Then integral over c f of z dz is equal to 2 pi I times sum of residues, that is sigma k equal to 1 to n residue of f of z equal to zk. So the integral of f is equal to 2 pi I times sum of residues, and we already studied few formulas. So now, okay, now what we will do is we will find all the singularity in the finite plane. Find all the singularities in the finite plane and find, so find all the singularity in the finite plane and corresponding residues. Show the details. So we will discuss few problems. Okay, so you check. First problem is we have to find out the singular points and residue at that singular point. So the first question is sin 2z divided by z raised to 6. Okay, tell me what is the singular point. Sin 2z divided by z raised to 6. What is singular point? How many singular points are there? Tell me. Tell me what is a singular point here? What is a singular point here? Where f of z is not analytic? Anybody? where denominator is becomes 0, z equal to 0. So the singular point is z equal to 0. Now we want to find out the residue. So we have few formulas, right? So one of the important formula is if f of z is of the form p of z divided by q of z, okay, and if z naught is a singular point, and if p of z not equal to 0 and q dash of z not equal to 0, also q of z naught is equal to 0, then residue is, we already studied residue of f of z at z equal to z naught is p of z naught divided by q dash of z naught. So we can use this formula if it satisfies this condition. So let us check whether we can do this problem by using this. So you have to check what is p of z here, uh, sin 2z, right? Now what is the z naught here? Z naught is the singular point 0. But here p of 0 is equal to sin 0, which is 0. So we cannot use this formula, right? Because if we want to use this formula, we need p of z naught not equal to 0. But it's already p of z naught is equal to 0. So we cannot use. So the method, if it happens like this, or if the numerator becomes 0, then the only method we can find residue is what we will do is okay. So what is definition of residue? Residue is equal to um, coefficient of 1 by z minus z naught in the Lorentz series. So what we will do is we will find the Lorentz series expansion of this with the center 0, right? So what is the center? Z naught is equal to 0. So sin 2z divided by z raised to 6. So this we can written as 1 by z raised to 6 into what is the expansion of sin z Maclaurin series expansion? Anybody?
Z cube by 3 factorial.
Right? 5 factorial minus etc. So then sin 2z is equal to, you replace z by 2z. So 2z minus 2z all cubed by 3 factorial plus 2z all raised to 5 by 5 factorial minus etc. So we will replace here 2z minus 2z all cubed by 3 factorial plus 2z all raised to 5 by 5 factorial minus etc. So, so this is equal to 1 by, okay, if I multiply this, we will get 2 by z raised to 5 minus z cube is there, and so this will be minus 8 by 3 factorial into z cube plus, so this is z raised to 5, 2 raised to 5 divided by 5 factorial into z minus etc. Right? So what is residue of f of z at z equal to 0 here? By definition, it is coefficient of 1 by z, right? So what is residue here? What is coefficient of 1 by z? Tell me.
2 raised to 5 by 5 factor.
Raised to 5 by 5 factor. So, so for finding residue of this problem, we cannot use that formula, but rather we will use Lorentz series and find the um, coefficient of 1 by z. Now I will take this problem 8 by 1 plus z. So next problem I will take next problem 8 by 1 plus z square. So so how to do this? What are the singular points? Tell me. Singular points are when
Plus or minus I.
minus I. Now we want to first find out residue at z equal to I f of z. Okay. And then we will find residue. So now let us check whether we can do by using that formula. So this is P of z divided by Q of z. So what is P of z here? 8, and Q of z is 1 plus z square. Now you check whether our conditions are satisfied. P of what first singularity is I. So P of I is here 8 itself, not equal to 0. Now you check what is Q of I. Q of I is 1 plus I square, which is equal to 0. So that satisfies. Now what is Q dash of okay, what is Q dash of Z? Q of Z is 1 plus Z square. What is Q dash of Z? 2Z. Now you check what is Q dash of Z, Q dash of I is equal to 2I, not equal to 0. So our condition is satisfied because here P of Z not equal to 0. That is Z naught is I here. So P of I not equal to 0. Q of I is equal to 0. Q dash of I not equal to 0. Therefore residue is P of I divided by Q dash of. So tell me what is P of I? 8 divided by Q dash of I. 2I. So this is 4 by I. Okay. So what is residue? 4 by 8. Now you find out residue at and tell me what is residue at z equal to minus if of z. Minus if of z. Anybody?
Minus 4 by
4 by I. Okay. So why that happens? We have P of minus I is equal to 8. Q dash of minus I is equal to minus 2I, right? So that is 8 by minus 2I, which is equal to this. So similarly, we can do other problems like this. So many problems are there. I will send you these problems. So we can use either we can use Lorentz series, otherwise we can use few formulas. Now I will give you another. What is so here. Okay, now while for doing this problem. e raised to e raised to 1 by 1 minus z, right? So this problem, how to do this problem? This is not in the form of p of z by q of z, right? It's not in the form. So what is the singularity here? Tell me, what is singularity here? Anybody? What is the singular point here? Where is function is not analytic? Denominator type e raised to something 1 by 0 is not different. So when it becomes 1 by e raised to 1 by 0, for what value of z? What is singularity here?
One.
Z equal to 1. Okay. So we cannot use this type of formula because it's not a rational function. So the only method is we have to find out the Lorentz series expansion. So e raised to 1 by 1 minus z we can written as e raised to minus of 1 by z minus 1, right? E raised to minus of 1 by z minus 1. So we already know that the Maclaurin series expansion of e raised to z is 1 plus z by 1 factorial plus z square by 2 factorial plus etc. So, so then what will be here? Here we will replace z by 1 by z minus 1. So sorry, now what is e raised to minus z? This is, we replace here z by minus z. Okay, so this is 1 minus z by 1 factorial plus z square by 2 factorial minus z cube by 3 factorial plus etc. So now here we will replace z by 1 by 1 z minus 1. So what will be the expansion? 1 minus 1 by z minus 1 by 1 factorial plus 1 by z minus 1 all square divided by 2 factorial minus 1 by z minus 1 all cube divided by 3 factorial plus etc. So what is the residue? What is residue? Residue of z equal to 1 f of z. We know that it is the coefficient of 1 by z minus 1. So what is the coefficient of 1 by z minus 1? Is equal to, so residue, oh sorry, minus 1. Good, minus 1. So residue is minus. Okay. So for doing this, you have to practice a lot of problem. ഒരുപാട് പ്രോബ്ലംസ് ചെയ്താൽ മാത്രമേ നിങ്ങൾക്ക് മനസ്സിലാവൂ. ഒരുപാട് ക്വസ്റ്റ്യൻസ് ഞാൻ തരാം, അപ്പം അതൊക്കെ ചെയ്ത് നോക്കുക. ഇനി നമുക്കൊരു ഇൻ്റഗ്രേഷൻ നോക്കാം. ഓക്കെ ഈ പ്രോബ്ലത്തിൽ റെസിഡ്യൂ കണ്ടുപിടിക്കേണ്ട കുറച്ച് ഡിഫറെൻ്റ് ആയിട്ടാണ്. അപ്പം നമുക്ക് ഈ പ്രോബ്ലം ഒന്ന് ചെയ്ത് നോക്കാം. സോ ഞാനൊരു വേറെ ഐ ഹാവ് ഗിവൺ അനദർ ഫോർമുല ഫോർ ഫൈൻഡിങ് റെസിഡ്യൂ വെൻ പോൾസ് ഓഫ് ഓർഡർ മോർ ദാൻ 1. ഡു യു റിമെമ്പർ ദാറ്റ് ഫോർമുല? Okay, so let me write this question. Um, so, I will write here so that we will find the integral over c dz divided by z square plus 1 all cube when c is mod z minus I is equal to 3. Okay. So let me do this problem. Okay, so how to do this problem? First you have to draw the curve. What is curve? C is mod z minus I is equal to 3. So that means this is a circle with the center I and radius 3. So this is I. So with the radius 1, 2, 1. Okay, so this is our C. C is a circle with center I and radius 3. Now here we have f of z is of the form 1 by z square plus 1 all cube. So tell me what is the singular point here? F of z is analytic everywhere except ഏതൊക്കെ പോയിന്റ്സിലാണ് at
plus and minus A.
plus or minus I, right? Now okay, so we know that integral over c now dz by z square plus 1 all cube is equal to, by residue theorem, this is 2 pi I into sum of residues. So now you have to check whether plus or minus is inside. Okay, I is already inside the circle, right? Is minus I is inside the circle, right? Because if you put here minus I, you will get minus I is equal to minus 2I, which is equal to 2, which is always less than 3. So that means I and minus I are inside. So here you can either write f of z is analytic everywhere except z equal to plus or minus I in C. So this is actually is equal to residue of z equal to I f of z plus residue of z equal to minus z. Now how to find out residue? Okay, sir. Is this about what type of singularity is this? F of z is equal to 1 by, you can written as z minus I into z plus I all cube. So what type of singularity is this? Is it a pole? If it is pole, then what is its order? Anybody? So what is z equal to I? Is a pole of order 3, right? Pole of order 3 alle. Why? You can write Lorentz series, right? Z minus I all cube into z plus I all cube. So this can be written as 1 by z minus I all cube into 1 by z plus I all cube. So if you want to write, this is actually analytic at z equal to I, right? So there must be it is of the form z minus I all cube into, if you find this can be written as z plus I you can written as z minus I plus 2I, right? Now if you expand this you will get some n expand this, get 1 by z minus I all cube into, if you write 2I outside you will get 1 plus z minus I by 2I. So if you expand this, z minus I all cube 1 by 2I into this expansion 1 minus z minus I divided by 2I plus z minus I all square divided by 2 factorial I all square plus etc. So this is always pole of order 3, right? So ഇങ്ങനെയുള്ള പ്രോബ്ലംസ് വന്നു കഴിഞ്ഞാൽ പോൾ ഓഫ് ഓർഡർ 3 ആണോ എന്ന് ചെക്ക് ചെയ്യാൻ ജസ്റ്റ് ഇങ്ങനെ ചെയ്താൽ മതി. ഇപ്പം നമുക്ക് എഫ് ഓഫ് സെറ്റ് പി ഓഫ് സെറ്റ് ഡിവൈഡഡ് ബൈ സം സെഡ് മൈനസ് എ ഓൾ ക്യൂബ് ആണ്, സോറി ഓൾ റേസ് ടു എം ആണെങ്കിൽ ഇവിടെ നമ്മുടെ എന്താണ് സിംഗുലാരിറ്റി എ ആണ്, റൈറ്റ്? അപ്പം നമ്മൾ എന്ത് ചെയ്താൽ മതി, ആദ്യം പി ഓഫ് എ 0 ആണോ നോക്കുക. If P of A not equal to 0, then ഇത് pole of order എന്തായിരിക്കും, M ആയിരിക്കും. മനസ്സിലായോ? സോ നമുക്ക് ഇതുപോലെ ചെക്ക് ചെയ്യേണ്ട ആവശ്യമില്ല. എന്ത് ചെയ്താൽ മതി, നമുക്ക് ആ സിംഗുലാരിറ്റി ന്യൂമറേറ്ററിൽ കൊടുക്കുക. അത് നോൺ സീറോ ആണെങ്കിൽ ഇതിൻ്റെ പവർ എന്താണോ അതായിരിക്കും അതിൻ്റെ പോളിൻ്റെ ഓർഡർ. ഇനി 0 ആണെങ്കിൽ എന്ത് ചെയ്യും, പോളിൻ്റെ ഓർഡർ ഒന്നും കൂടി കുറയും. ഓക്കെ, സോ ഹിയർ ദിസ് ഈസ് പോൾ ഓഫ് ഓർഡർ 3. Now how to find out residue? Residue of z equal to I f of z. We know that there is a formula. If pole of order m ആണെങ്കിൽ there is a formula, right? 1 by m minus 1 factorial derivative of m z raised to m minus 1 into z minus I all cube, or z minus, okay, sorry, z minus, if a singularity z equal to a is a pole of order m ആണെങ്കിൽ the formula becomes z minus a all raised to m into f of z, where z equal to a. So this is the residue formula. So here our f of z is 1 by z square plus 1 all cube, right? 1 by z square plus 1 all cube. So how to find out it? Here this is pole of order. Here z equal to I is a pole of order 3. Therefore residue of z equal to I 1 by z square plus 1 all cube is equal to 1 by 3 minus 1 factorial into d raised to 3 minus 1 t square by dz square into, what is it, z minus I all cube divide into 1 by z square plus 1 all cube. So this is if we find now this will become very easy. So this is 1 by 2 factorial into d square by dz square into, this is z minus I all cube into 1 by z minus I all cube into z plus I all cube. at z equal to I. Now this and this get cancelled. Minus second. So now you find out this is equal to 1 by 2 factorial into second derivative of 1 by z plus I all cube. Now you find out the derivative at that. Then last I will 1 by 2 factorial in d by dz of what is the derivative of this? Minus 3 divided by z plus I all raised to 4. This is equal to, if you differentiate once again, you will get minus 3 into minus 4 divided by z plus I all raised to 5. That is z equal to. Now this is equal to 6 divided by, if you put z equal to I, 2I all raised to 5. This is 6 by 32 into I raised to 5. This is equal to 6 by 32I. This is equal to minus 6 by 32I. Okay. So y minus, because 1 by I is equal to minus. So this is the residue. Now you find out residue of f of z. ഇതിൻ്റെ റെസിഡ്യൂ കണ്ടുപിടിക്കുക z equal to minus I-ൻ്റെയും എന്നിട്ട് add, and then you add both and you will get the answer for this integration. Any doubt?